Welcome everyone. I'm Amy Pilling and this is Alicia Guzman and August Muth. And Alicia and I work for SciArt Santa Fe. This is our last laser talk of the year. And it's very appropriate, Return into the Light with August Muth. SciArt Santa Fe is a little nonprofit in Santa Fe. We're fairly new. And we're one of over 36 hosts of the Leonardo Art Science Evening Rendezvous, which is, the acronym is LASERS. And they're international hosts, so they're all over the world. And we do these in coordination with the Leonardo Society for the Arts, Sciences, and Technology. And SciArt Santa Fe works at the intersection of art and science, and we do public programming that brings artists and scientists together. We focus on people who integrate art and science, and we also do educational programming for the public. So I'm going to ask, if you have questions, please ask questions in chat, and then some people will use Q&A, that's fine too, and you're welcome to ask questions and make comments. And what we'd really love is for you to introduce yourselves to each other in chat, because it's always a very interesting group of people who attend these, and that way you can connect with each other if you'd like. And that is it for me. I'm going to pass it on to Alicia, who will introduce August.
Hi everybody, I'm Alicia. We're streaming to you from Santa Fe, or ancestral Tewa lands, Ogapoge. I'm so happy to introduce August Muth. For more than 30 years, Muth has been an internationally exhibiting artist and a pioneer in the exploration of light through holography. His interest in light began at the age of 16 when he began making large water-filled glass prisms, which he used to refract prismatic light upon his family's garage door. In 1973, he left Albuquerque to work as a jewelry maker in Aspen, Colorado, where he became captivated by the light of opals and diamonds. Upon returning to Albuquerque the following year, he began his studies in art and physics at the University of New Mexico, and later continued at the University of Houston and the University of Texas at Austin. Muth moved to New York City in 1978 to begin walking the path as an artist. In 1980, he began his holographic exploration at the Museum of Holography in Soho under Fred Osterschner. He relocated to Telluride, Colorado in 1985 to build his holographic studio, and spent the next 7 years honing his skills in the Denisha single beam holography technique. During this time, his interest in the relationship between light, space, and time intensified, requiring a studio expansion. In 1994, his studio was reimagined and constructed here in Santa Fe, New Mexico. In Santa Fe, the desire to produce larger holograms became a priority, and for the next several years, he spent thousands of hours developing techniques in this quest. Trial and failure became a large part of his practice, since large-scale single-beam holograms had never been produced by anyone previously. After a pivotal insight which resulted in the discarding and total metamorphosis of previously learned processes, he was able to create holograms in a greater scale. Muth continues to produce works exploring light space-time continuum in his Santa Fe, New Mexico studio. So with that introduction, I would like to welcome August Muth to today's laser.
Thank you. It's very nice to be here. Oh, let's go. Here we go. Why aren't I? There. But I'm seeing her on the screen. There we go. Sorry, it took me a while. This is all new to me, so it's a learning curve, and we'll get there. Anyway, it's very nice to be here and to have been invited by Laser and the SciArt organization in Santa Fe and Leonardo to give this presentation. So here we are, getting ready to go into the solstice, the winter solstice, happening about 2 a.m. in the morning here in Santa Fe tomorrow morning. So we'll start with a image. And this is an image of ice crystals that form halos in the atmosphere. And there are many different halos in many different dimensional aspects here. It's not, of course, it's a photograph, so you're seeing it as a flat image, but if you see something like this in real life, you have multiple halos, going in different directions through the atmosphere. And it's just a wonderful experience. And I've experienced this a few times, actually, up in Telluride, a couple of times on top of the mountain when I was skiing. I had experiences like this, and they were just caused me to stop and just hang out for a while and enjoy it. So let's share another one. Oh, it's not here. Well, that's the way it goes. I was looking for the halos hologram, Cleopatra. Where did it go? Well, anyway, so let's talk about light. We are.
Got it? And if you can't see it,
It's here. So you can see this. You can see this. Basically, the electromagnetic spectrum. And
Yes.
this is what we experience on a daily basis. This little line that's very small is only, a little short aspect of this electromagnetic spectrum, which extends actually far beyond this thing. As I'm reading, lately I've been reading about gravity waves and the wavelength. Some people, hypothesize that the wavelength of gravity waves, which are basically the same thing as light waves in one respect, are the dimension of the universe. So, we sort of live in this huge thing of waves interacting and creating a interference pattern throughout our experience on the planet. And let's see if we can go to another. So we'll look at some work right now. So this piece has some reference to halos in that they're ovals in space. What I have done with this piece is actually remove sections of the hologram so that you can, see if I can stop this real quick. No. Well, didn't get there. Sorry about that. So we'll go back here. So that piece, holograms have this property where they record the entirety of the information of what the hologram is being made of on the entirety of the holographic recording plate, in essence. And so that piece is really about removing sections of the emulsion so that I actually was removing sections of the emulsions, trying to unresolve the image of those two ovals. What was interesting is that if you look at the real piece, it actually does just that. It unresolves, and you really have a difficult time resolving, these 2 3-dimensional images of ovals. Whereas if you take a video of it, it seems to resolve itself. So that was not really the video I wanted to play, but that's what came up. So that was, so we'll try to go back and start where we were, where we wanted to start. There we go. Well, we'll share this one. Why is this not going away? Okay, we'll try this. So this piece is entitled Trace of the Traceless. And what it's really about just a hologram of light itself. And oops. And as you move from left to right viewing this piece, it changes color dynamics tremendously. And so it's very interactive, and it's you know, as usual with my work. Here, we'll go look at it again. You know, as you can see, like from this left side, you're having a transference into magentas and pinks, and now the orange starts coming in, and that line that you see in the piece is actually a sandblasted area where I've filled with a photoluminescent pigment. So after you've enjoyed it for a while, you know, with a light on it, then you turn the light off at night and it'll glow for about 8 hours. And it's a very, you know, interesting study in light. Let's see, let's go over here and let's get rid of this one. Okay. Not again what I wanted to show right now, but we're here, so we just keep things moving. So this piece is also has luminescent pigment in it, and it's oh gosh, I'll think of the title in a second. It's +1 nanosecond. It's basically about the Big Bang, and so 0 to +1 nanosecond is the title of this piece. And does the glow come out? No, the glow doesn't come out. We'll try it again for fun. So once again, you know, this piece really is interesting in that it is really about light itself. As you move around the piece, it changes color dynamically, as you can see here. And all of my work is very interactive, and you have to get involved in the experience of viewing the hologram. So it's always really difficult to, you know, for me to see videos of my work, because for the most part, it doesn't really say what I'm really trying to say. Because it's such an experience to be involved with these pieces. So is this another hologram that everyone has seen? Yes, it is, I believe. So this is called acceleration number 4. So actually, when you are, you know, about in this position right in front of it, this blue square that you're seeing extends out about 9 inches from the surface of the glass. And it has a physical presence. And that's one of the experiential aspects of my work is what I call material light. And you know, holograms are sort of these very strange things that are able to transform an immaterial, or not, I shouldn't say immaterial, non-material substance of light into something that has material, something that has physical, that occupies physical space, and it's very enticing to be able to interact with these pieces. So I'll go one more here, another artwork. Mhm.
I don't think this is playing.
Oh, it's not playing?
For
Okay.
them. Yeah, just go to, where's the one that, is this the one that is open?
We'll just stick them all over there. How's that?
Yeah. There you go. Now I think this is the one. Yeah.
So hopefully I'm sharing a piece right now. This is another piece that has a rectangle projecting out into space, which is white. And then behind that, there's a sort of a greenish turquoise green rectangle behind it that creates a multidimensional space between the two of them of, you know, a foot at least, you know, but it actually seems more active and more interactive in terms of how one experiences it. And you can see the green square on the right-hand side now that's in the depth. And as you move around, you can sort of get a sense of what it is. But seeing my work in person is very enticing, I feel. So what are we doing? Okay, so let's where are
I have to go open it again.
open?
What are you looking for?
I'm looking for the videos
Oh,
of
just,
videos of the studio. Okay, there we go.
there, so just
Okay, now we're going to take a little tour of our.
oh,
No,
you get a double, just double click it there.
double click it.
Yeah.
Okay,
Then go back to your Zoom.
go back to Zoom, and then share.
Mhm.
Okay. Okay. So this is entering the actual area where we make the holograms. This table where we're making the holograms on weighs about 14,000 pounds. And the reason for that is because we have to isolate the production of holograms in a very isolated way. If anything moves more than a 10 billionth of an inch, you don't get a hologram, which is sort of always makes things interesting. These are some of the lasers I use over here. They're argon. The larger one is an argon laser, and the smaller one is just pretty much a laser that I align things with. And then we'll move over here, and this is another holographic table we have. It's not quite as large, but it's also enjoyable. So this is a large concave mirror I have. It's sort of interesting. This is sort of other people who are joining us who are holographers. They might really enjoy this, but also people who like fun houses will enjoy this. So what I'm going to do is just basically just walk into the focal point of the mirror and then move the camera past that focal point. Here we go, going through. Okay, right there is the focal point, and then we end up, and now we're on the other side of space and time. So this is all sort of a crazy, enjoyable experience that we get to do. And we do this on a daily basis here. We play with light often. One thing that I recently have done is to, that's the shooting room, okay. Okay. Let's do the interferometer. So now we're going to have a little bit of light fun. And basically what I did was create an interferometer, which is something that measures the light wave interaction of laser lights. And so what I did was to interact 3 colors of laser. So here we go. Here's the lasers. You can see that they're sort of going through space. And they hit this beam splitter right here. Actually, let's continue. They hit these 3 different beam splitters that are picking off parts of the laser beam. And then they come back through to this main beam splitter that we just passed a little earlier. And you can see the 3 colors of laser have interacted, and then we expand that interaction with a lens, and what you get is these lines that are representing how the laser light is interfering with itself, creating bands of light and dark. And as I hit the table or as I touch anything on the table, it moves enough so that the interference just totally stops interacting with itself. But here we are, here, nice, strong, those are very strong fringes, and that's you know, means everything's really lined up very, very well. When they get a little further apart, it means that they're not lined up quite as well. So what I was doing is just having a little light show here and enjoying a 3-color interferometer, which I had never done before. And I didn't even know if it worked, but it worked quite well. So let's see. Shooting room, interferometer. Nope, wrong one. Wrong one. Well, actually, we'll just do this a little bit more again.
But still looking at the other one now. Yeah.
Oh.
Green. Yeah.
Okay, so this is the setups that I use to make holograms normally. So the laser comes out, hits this mirror, and then goes up to this pole with a whole, you know, variety of different concave mirrors on it. And what happens is the mirrors act like lenses and they spread the laser beam out. And so the laser light goes up to these mirrors and then reflects down. And because it's concave, it expands the laser beam. And then here is how I would make the hologram. So I have a piece of emulsion that I've coated onto glass that is supported above a 3-dimensional sculpture of a halo. Ooh, that's where it all started, was in the halo. You know, that was one of my very first inspirational points, was seeing halos of light in the winter sky and wondering how I could be able to produce those into a hologram. So here it is. And basically the light goes through this piece of glass with the emulsion on it, and then that light reflects off of the subject matter, and then those light waves come back up through that emulsion. So that's how you get that interference of laser light waves, which is in essence what was happening when I was showing you that interferometer and the interaction of the light waves. So the fringes, when the hologram is being made, has to be held very tightly so that any movement or instability anywhere creates a situation where the hologram just doesn't work. It doesn't interfere with itself in the way it needs to be to create the holographic image. So that's why it's so important to have a very stable and quiet area to make your holograms in. What do we got here?
That's nice.
Oh, oh, great. Okay, so this is C. Alex Clark, a colleague, assistant, helper, and an artist definitely in his own right. And this is a project that he is doing, which is a transmission hologram, which is a different thing. So basically, he's just making holograms of light itself. And you basically interfere the light. That project is he's shining laser light through lenses, and then on the making a hologram of where those lenses focus light in space. So it's you know, we have a lot of different things going on here. I have, you know, 5 different holographic tables that we do projects on, and often when we're doing holograms, there are many setups on numerous tables. So I might do, or we might do, 8 or 9 exposures in one period of time. And you sort of have to do it that way because the lasers we use take a long time to stabilize. You have to turn them on and then wait about 3 hours for them to really thermally stabilize, so that the light coming out of them is very stable and is not moving in a way that would be shown by the interferometer. So these are sort of the, you know, the challenges we face, but also, you know, the excitement we have when something, as many holographers will say, goes wrong. I actually utilize a lot of times when holograms move and you get these effects that will only happen once. And it could be because the glass bent during the exposure. It could be, all sorts of different reasons. A truck going by during the exposure time, and it just put just enough vibration in to make things just move just a little bit. And then you get these odd and strange effects. All right, let's share something else here. Let's go here. Oh, that one's not it. That one's not it. Here we go. So this is basically the interferometer that I showed you, and this is really the basis of holography, is interfering light waves with themselves. And so you've got the laser, it hits the beam splitter, and it takes part of the beam in one direction and lets part of the beam go through, and it reflects directly back upon itself, and then you get that interferometric reading. And it's just a lot of fun to play with. But also it's basically the same manner in which gravity waves were discovered a few years ago. They set up, there's a big interferometer up in Washington and a big interferometer down in Louisiana. And they basically took readings, and they were taking readings of wavelength shifts, basically about half the diameter of an atomic nucleus. And so it's sort of, you can really measure very, very small dimensions with an interferometer. It's, if not the best, measurement device around, which I have a feeling it is. I haven't done a lot of research, but it's all within the analog world. It's not within the digital world. And this is an important aspect of holography, because right now there is a lot of people exploring digital holograms, and they're very intriguing image making tools. But for me, the true hologram, the real hologram, is the essence of light itself, because you are really starting to understand light in a very new and dynamic way that people really haven't looked at light and understand light. And, you know, and as we move through our future, you know, light will become more and more important in how technology evolves, but also how, you know, we evolve as a human race by, you know, utilizing the sun to a larger degree than we do right now, because that's really the source of all life is the light that comes from the sun in one level or another. And so, you know, to really appreciate that is really what my work is really about, is trying to help people understand light and to understand mystery and to really get involved in the dynamics of how we enjoy this environment we're in, and to understand beauty in this time, especially in this time where we have such difficulty. Beauty, I feel, is really an important aspect, and wonderment's a really important aspect of what we need to be engaging ourselves in and expressing in our lives. So maybe this is a good time to see if we have any questions. Let's see where we're at.
Please ask questions in chat if you have anything, you know, for Augie. And then Augie, you see where chat is?
I see where it is.
Respond directly, or?
Okay.
I saw someone was asking about the size of these pieces. And I'm curious.
Yeah. Well, the size of these pieces, you know, the one over my left shoulder is about 26 inches by 21 inches wide. We have been working on larger pieces of, it sort of became a difficult period of time the last year, as everyone knows. I did a lot of redesigning and rebuilding in my studio over the last few years. And when February hit, I was basically just getting ready to really jump on making much larger holograms. And but we're dealing with glass, and it's very heavy. So for the last 6 months, I've really stepped back and only been really making smaller pieces. But we are progressing soon here to be able to do pieces that are 36 by 44, and then I'm also set up to do 4 by 5 foot pieces, but that might take a year or two.
Neville Bean asked, when the holograms feature shapes, what are the physical objects you are shooting?
Well, usually I create sculptures, small sculptures, you know. I used to do very detailed pictorial sculptures 30 years ago. But since then, I've basically, in the last 20 years, really gone to very minimal forms, just to really have people really interact with the light more than with the subject matter, in terms of it being a pictorial subject matter. And so that is I think a very important part of my work is to try to remove the pictorial. And so that's one reason you see many rectangles and many rings in my work, because the ring actually has a little bit more pictorial content than the square. So as of late, I'm using a lot of squares and a lot of rectangles, and just playing with light in space.
We have a question from Andrea Poli. She asks, she would love to understand more about the materiality of light scientifically, philosophically, and or spiritually.
How long we got?
How long do you have? Yeah, really. You know, I mean, it's sort of, you know, light is something that we really don't even know, you know, what it consists of. I mean, it acts like a wave sometimes, it acts like a particle sometimes, and expresses itself in all sorts of different manner. And it's something that we need in our lives to survive. And, you know, basically 99.9% of what we know of the universe is all received through information carried on light. It comes from stars and you know, and it could be of different frequencies. And when I say light, in one sense, I'm also talking about the electromagnetic spectrum because it's all sort of the same stuff. But, you know, with my work, you know, I think holograms they're very unique because they really take light as something in this non-material substance and materialize it into something that we can interact with physically in time and space. And, you know, with with acceleration, the piece, pretty much any of the pieces that have a rectangle in the piece, as you walk up to the piece, that rectangle grows and grows in size until you actually enter through it and you can go through it. And it's like a veil of light that's out in front of the glass material of the piece. And you can interact and you can, you know, move in and out of that. And you can, if you take your time and patience, you can actually feel that light inside your eye because it is existing in a physical space, literally a physical space in space. And that's one of the most amazing things about this medium is that aspect. You know, and there's, I mean, the holographic world and the principle that, you know, many physicists talked about really relate to the hologram to you know, entanglement, you know, literally what is it? Quantum entanglement is what I was trying to think of. And these are things that are really difficult to really comprehend. You know, one of my favorite experiments is the double slit experiment. Go to YouTube, look for double slit experiment. There's a whole bunch of videos there and a lot of different people talking about the total mystery of what happens. So, you know, you have to see a hologram. That's the best way to talk about material light, is really experience it. So when things open up again, I will be, you know, having, you know, open studios, and then I show my work. I've got a show coming up sometime in the near future in Santa Fe in Currents Gallery on Canyon Road. And it was supposed to open December 4th, but it was postponed, and we'll see when it happens. But it will be the next show that they put up. So I'm looking forward to that.
So we've got a bunch of great questions, Augie. So I'm going to keep reading down the list.
That sounds great.
How long does it take from idea to a finished hologram?
35 years. No, it takes a long time. You know, it's a very labor intensive medium. And so, you know, basically you have to come up with the concept, construct the framework, the sculpture, you know, of what I'm going to make the hologram of. And then you have to coat an emulsion onto glass, and then you have to age it a little bit so that you get just the color balance you want. And then then I make the holograms, and then I laminate the holograms together and finish the glass. So, you know, each piece broken down to hours, you're looking at between, you know, 25 and 55, 60 hours in each piece to produce it. This piece over my right shoulder, don't have a video of it quite yet, but it's new. It's in here? Okay, where is it? Let's talk about it, because it's a fun piece. I just finished it last night. We're looking for it. Well, actually, that doesn't really work. That's, you go to the gallery. So this is what my little interior gallery in my studio looks like. It's a space where I show pieces. That piece is a spherical light piece, which is really just about light. Here's a brand new piece. This is that blue square that's floating out front is sticking way out. And if you walk into it, it just totally fills your consciousness. There's a halo piece. And I wish I could have gotten the Cleopatra's. You know where you can get Cleopatra video? That would be great. And so here, these are very spherical light pieces. These are very simple.
Later on in this video.
Okay, yeah. Sorry.
So here later on in this video.
Well, there's another Cleopatra is great because it's got 3 lights on it.
So here's the
Oh yeah, okay. So they were going into it. And of course, since you're looking with a video camera, it doesn't really, you don't really get the sense of the expanse of it, but that blue color really wraps around, you know, you enter that space. And it, you know, as you get right in it, you look up and around the entire piece, and that entire dimension of the glass structure is filled with blue light. And yeah, this is this new little piece, which is turned out exceedingly well. It is like a color study of multi-dimensional aspects in every way possible. So this is a very, as you can move down, it has, you know, kinetic dynamics in there, and as you move up, it also has a kinetic characteristic. So that's the way the holograms that we make here, which are Denisha holograms, invented by Yuri Denishuk in Russia. He's my hero in many ways. It was interesting to meet him. He can sure drink a lot of vodka compared to what I can put down, I can tell you that. So
Augie,
this is real cool. Let's just look at this one real quick. So this piece is called Cleopatra, and right now there's a single light source on it. This is sort of the Halo series that I've done. But what's going to happen is here we have multiple light sources on it and even more multiple light sources on it. So it's sort of the same thing as what was going on with that initial photograph that I showed you with all of the dimensional rings of light in different multi-dimensional aspects. So there we are.
Well, I'm going to keep reading through questions, and
Okay.
I'm thinking we have lots of questions. So I'm thinking we'll record the chat, and anything we don't make it through during the laser, you could answer afterwards. But we can go on longer if everyone wants to do that. And Augie, if you're up for that.
I'm fine.
Okay. Melissa Crenshaw asked, do you have a favorite playback lamp?
Yeah, the sun, by far. I actually have a lot of holograms scattered around outside my studio, and it's partially because I really like to look at them in the sun. I like to look at them on cloudy days. I like to look at them in all types of conditions, and also just to see how they're doing, in time in weather. And so far, 20 years down the road, we're looking good.
Okay, we have another question. I hope you tell us more about the process of coating of the glass plates. That comes from James Graham.
Well, it's sort of a curtain coat is what I do. So I coat a piece of glass with emulsion and a bottle, and then I put it on a turntable and spin it. So it's fairly simple. I do have a video of and sometimes plates fly off the turntable and crash across the room, especially the big ones. So we start them up and then we go in the other room to let it dry. So but that doesn't happen very often.
Okay, we have a question from Heather Murphy. Where can we see your work in person?
Right now it's a difficult situation. because I've got galleries in New York and in Houston, and they're basically closed. An appointment, it's difficult to even get an appointment to go to these places. My studio is a possibility in Santa Fe. And the best thing to do probably is to email me, and I will put you on a list. And when things open up a little bit more, I'll be able to let you know, where I'm having shows and where you can see the work. So it's augustmuth.com, which is fairly easy to find.
Okay, we have a question from Lex, a technical question. I know in the past you worked with DCG. Is that still your main medium, or are you also working with silver halide these days? Photopolymer?
Just DCG. It's it's the colors that I can realize with DCG. I haven't seen any other emulsion that can realize the same type of color dynamics and aspects. So DCG is for people who don't know a lot about holography, it's sort of an very old school, very hands-on technique.
Okay, we have something from Jawa. Are there any opportunities for artists to come and learn from you or to create work in your lab in the near future?
Occasionally, about once a year, we do a workshop. We did a workshop something like a year and a half ago that was connected with the Currents New Media Festival, and that will be happening again. Hopefully, the festival will happen this summer, and it's really, once again, as soon as things open up, there will be possibilities.
Okay, we have something from Tony. How do you create the magentas and pinks?
That's one of those things of just working with the emulsion for years and years, working with different formulas, because it's I mix my own emulsion to coat the plates, which is it has a brotherhood with early photography when they used to coat plates on emulsion. Coat emulsion on the plates. It's just it's a process of figuring out formulas, and different gelatins affect it, and just making holograms. And in terms of the magenta, like exactly, I have made magenta holograms with one exposure, but it's a lot easier to put two holograms over one another, a sort of an orange one and a blue one. And then that's how you can get, the magenta to do its thing.
Okay, we have a question. Can you please give us your top 3 books in holography? This is also from Java.
Well, a book, the Holography Handbook by Fred Unterseer, I think is the most interesting hands-on book in terms of learning about holography, the philosophy of holography, and many different aspects of what it is. There's some other authors out there who've done books, but they're more technical. It sort of depends on if you're wanting to go in a more technical direction or more hands-on. In the beginning, I would go hands-on with Fred Unterseer's book.
Frank asks, are you saying that a more accurate measurement can be achieved with analog devices versus digital devices?
Absolutely. I mean, it's the discovery of gravity waves was through an analog device, and it was measuring atomic particle size measurements. It is we're in a stage in technological development. We're in a digital stage, and it's really temporary, because soon as we really evolve quantum computing and really enter the age of light and photonics, that computing system does have the ability to go back into the analog world and work in an analog system of information, because all the information we get from all the stars in the universe, that's all analog information. We sort of translate it digitally into a language which we can manipulate through, but it's really not, it's not the pure thing. It's not the pure information.
Anna says, oh, okay, sorry, I didn't mean to interrupt.
No, go ahead.
Anna makes a comment about the massive hours at the beginning of all of you figuring out the film formulas and how much that had to do in terms of really understanding the medium.
Yeah, I mean, Anna MacArthur she worked with me. We were together for many years, and she started the first holographic lab in Norwood with me. And I'm still trying to figure it out. You know, it's not, it really has not been defined and figured out totally at all, you know, and I find things out continually, but it's yes, it takes a lot of work to do this. And you know, my wife, Joan Stango, she's scratching her head all the time saying, how can you just keep doing this? Even though, you know, she understands it, because she's a musician and she plays music often.
Then we have a question from Mark. Any plans to take 3D 4PI pictures in the gallery that could be experienced in VR, in virtual reality? That would be awesome.
You know, I've thought about it, but it's sort of, once again, it's one of those things where you're going into the digital realm, and it's really it would be an illusionary experience, and I would rather people experience it in real life. And so that's part of the problem of you know, our current situation is, you know, close interaction. But you know, I think there's probably other people who are looking into doing that, and we shall see. Oh, I see a friend of mine ask a question. Tell us about DNA encoding into pulse holograms. Well, this is a whole other realm where there's the degree of information that light can hold is maybe infinite. There's definitely some scientists who have expressed that in things that I have read. And so, you know, there are these types of holograms where you can make a hologram of a person. And the exposure time is very short because the person can't move more than a 10 billionth of an inch, blood flowing through the body, all these different aspects, and you can't move. So the exposure time is, you know, in the range of 6 to 12 nanoseconds, nanosecond being a billionth of a second. And so when that light, the laser light hits the body, the light can go into, it penetrates into the skin and can reflect back out of the skin. And when it comes out, it can be carrying an immense amount of information. Just as we look at a star, there's an immense amount of information in that light that comes from the stars. So that light coming back can be recorded into the hologram because the size of the photon is small enough to really interact with the DNA and carry out the DNA information. So this is all, you know, this is all sort of a you know, off the wall, multidimensional theory that I've sort of come up with over the years, looking at pulse holograms and thinking about how the ability of light to carry information.
We also have a comment to take our hats off to Richard Rallison, apparently who taught us the very first baby steps in making DCGs.
Yeah, I worked with Richard in the early days. He was a very interesting person. Didn't graduate from high school, but probably one of the two most intelligent people I ever met. And he at one point worked with NASA and helped to reconfigure the optics of the Hubble telescope when they sent it up and they had the wrong optical configuration in it. So he was a very interesting guy, and you know, I experienced A lot of information exchange from Richard, but a lot of the technology I use is sort of based with him, but I have really gone in a very different direction from how he used to make dichromate holograms. And one reason is that's one of the reasons why I can make larger holograms, because you know, Richard, I went to Richard's studio once, and he was making a 18-inch square hologram, and he had 55-gallon barrels of alcohol boiling in outside that he was processing these holograms in. And it was like, there is no way I am going to be boiling alcohol. It just was way too dangerous. So that's sort of one of the Richard stories.
We have another question through the Q&A part of Zoom from Sally. And she says, work looks great, Augie, congratulations. Please mention the thickness of the panels versus the depth of the light images to give a sense of the physical versus non-physical / light dimensions.
Okay, well, yeah, so the pieces are usually about an inch thick. They're glass and they're heavy, and that's one aspect that is I sort of like about my work, is making it heavy, because it's sort of a contrast of light and heavy. And so they're about an inch thick. Often, you know, the holographic material light, structure will exist 10 to 12 inches out in front of the glass surface of the hologram and 10 or 12 inches behind the glass surface of the hologram. So, you know, they're up to, 24 inches of volume at times. And of late, I've been experimenting with some very diffused imagery, you could say. So I'm really trying to just create light in space at a more intriguing level, even though for the casual viewer, it may be not as understanding, but that's what artists do. We work at the edge, and then we maybe step back a few steps to get something that works well with people who are looking at and appreciating the work that we do.
We have another question by Francesco. He asks, Augie, did you register a single exposure with 3 laser colors?
Have I done that? I haven't done that, no. I've done it with 2 different colors, but I haven't done it with, 3. When you said 3 colors, I was thinking of red. The emulsion I use is really not sensitive to red. But yes, I've done it with 2 different colors with DCG. DCG is pretty much, only sensitive to green and shorter wavelength. So it's green, sort of a blue-green and a blue, but, the color that I'm able to achieve has something to do with the wavelength of that I make the hologram with, but not totally at all. I can make very orange and red holograms, and those are actually made with green laser, because I can shift or process the emulsion in a way to get that orange or that red. And also you can shoot holograms with a green laser and end up with blue holograms too, but I use blue lasers to really get the really blue, deep ultraviolets that I love so much.
We have another question from Anna. Are you still using the Spectraphysics 124 argon water-cooled laser?
I use argon lasers. I mean, I every time I turn on an argon laser, I think of the aurora borealis, because that's in essence, that's the same light. And I feel really lucky to be able to work in the environment of the aurora borealis, because these are these natural light phenomenons that that I try to reference in some way in my work, it's it's always interesting to work with laser light. It's just a beautiful, it's a material. It has this material presence that, that when you're in its presence, you begin to understand light at a new level.
So do we have other questions? Anyone have anything else through chat? It looks, Augie, like we've made it through all the questions. Oh, wait, I see something else coming in. Paul Biaggi, did I hear you say that you layer one hologram over another to get some of your colors? Absolutely.
Yeah, I mean, that's one reason I utilize dichromate, is because it can be a very clear emulsion. And so I'm able to layer one emulsion on top of another, on top of another. Actually, if you look at the hologram over my left shoulder with the rings, you can sort of see this oval shape in the center, and that is one emulsion that is layered atop of another emulsion. That hologram actually has 3 layers of emulsion. And then the geometric figure is sandblasted into the back of the glass of that piece.
So it looks like we've made it through all the questions and we're spot on time.
Amazing.
So,
well, I really enjoyed this. Maybe by next time I will have a better idea of maneuvering through Zoom, but I will probably be doing something like this again. And because there are a number of things that I didn't get to because I wasn't able to, because I couldn't maneuver very well.
Well, thank you very much. And thank you everyone for great questions. And please watch SciArt Santa Fe or sign up for a mailing list. We just got a grant for a very interesting laser series coming up in the spring. So watch for that. And thank you everyone. And we will have a recording of this for anyone who would like to revisit. So thank you all very much.
And thank you. I really enjoyed it.